Creationists always ask how one species turns into another. It's a good question, but it's hard to answer them because they seem to have a messed up idea of how it works. Let's say you have fish and tetrapods. The creationist wants to know how one turns into another. So you show them a transitional, say Tiktaalik, and expect them to be reasonable and get the idea, but they don't. Instead, they say that you've only created 2 more gaps that need to be filled. As near as I can figure, they have this idea that fish go on just as they were, and then suddenly turn into Tiktaalik, which then turns into a tetrapod. Filling in another gap with, say, Ichthyostega doesn't solve anything because it's just put in one more that needs to be explained. If that's the case, then it's no surprise that they reject it. I would reject that theory too if someone proposed it, but that is not what the theory of evolution says. Consider this gradient. It's black on one side and white on the other, smoothly moving from one to the other. This is more like how species transitions work. Consider the horizontal dimension to be time, and the species slowly changes over the course of it. So the question might be, at what point does the black species turn into the white species? You could place the point at 50% gray, with some justification, but the color immediately to one side, considered part of the black species, and the color immediately to the other side, considered part of the white species, are almost identical, and certainly more like each other than the black or white on either extreme. So you propose a transitional species, gray. This species is from 33% gray to 67% gray. But you still have the same problem with the similarities of specimens near the boundaries. Here you see the problem. We as humans want to divide things into categories, but nature, apparently, does not share this desire. Indeed, the definition of species is a hard one to pin down. The basic definition is, if 2 organisms can produce fertile offspring, they're the same species. So if 2 species cannot reproduce with each other, they're different species. If they can reproduce but the hybrid offspring is sterile, as with a donkey and a horse producing a mule, then they are still of different species. One thing that messes up this definition is humans. We can put species in the lab and force them to reproduce, or splice their genes together and make a hybrid, but this shouldn't count. So the definition had to be revised to 2 organisms that can produce fertile offspring under natural conditions. But domesticated food animals, such as turkeys, cannot mate with each other at all, although wild turkeys still can. And farmers have to reproduce them by artificial insemination. Does this make each turkey its own individual species? The biggest corkscrew in the works is ring species. Consider Ensatina salamanders, which live in a ring around California's Central Valley. As they migrated, they separated into 19 separate populations, which became more and more distinct. By the time they met at the other end, they had become 2 separate species. But each species can produce fertile offspring with its neighbor, making them technically of the same species. The only difference between a ring species and any other 2 species you might find is that the intermediates are still alive. If something happened that wiped out all of the salamanders except the ones on the eastern and western ends, you would undoubtedly have 2 distinct species, even if they themselves haven't changed one bit. To help you find a better way of thinking about it, I'd like to introduce you to a concept we use in computer science, fuzzy logic. In traditional logic, a number is either a member of a set or it isn't. This is akin to how creationists, and probably most people, view species. A specimen is either a member of a species or it isn't. But as we've just seen, it's not that simple. A fuzzy set allows a number to be a member of both sets to varying degrees. Let's go back to our gray bar. If we number the shades from 1 to 100, then 1 is definitely black, 50 is definitely gray, and 100 is definitely white. They each have a membership of 1 in their respective sets. But there's a fuzzy area where they cross over. You might consider shade 10 to be black and shade 30 to be gray, and in between you have a movement from one set to the other. So shade 20 would be half in the black set and half in the gray set. Its membership in both sets would be 0.5. It is an equal, though not perfect, fit to both sets. Likewise, 15 would be 75% in the black set and 25% in the gray set. Now don't get this confused with probability. The color is what it is. It doesn't have a 75% chance of being black. It has 75% membership in the black set. So for example, Archaeopteryx, although officially classified as an ave, would not have a full membership in the bird set because of its dinosaur features. It might be considered 75% in the bird set and 25% in the dinosaur set, or whatever portion of morphological features biologists determine fit with each category. Whereas Deinonychus may be considered only 20% bird and 80% dinosaur. We can graph out this fuzzy set, where species with a membership of 1 in the bird set and 0 in the dinosaur set for all birds, and vice versa for all dinosaurs. The transitionals would fit in along the line between the two. So species are nowhere near as distinct as many people believe them to be. It's really just a category made up for human convenience, and although there is somewhat of an objective definition, it's still evasive, and there is much debate among biologists as to what should be considered a species. Now you may think the difference will be clearer the further up the taxonomic ranks you go, but if anything, it's even fuzzier. Unlike species, which at least has an attempt at an objective definition, none of the other taxonomic categories do. It's purely a human contrivance, and although biologists arrange it in a nested hierarchy, which is completely real and objective, and can thus make taxonomy reflect the organism's position on the evolutionary tree, the point where one thing becomes another is still quite fuzzy. Incidentally, don't get confused here. There is no fuzziness between the branches of the tree. Having such an animal, a sort of crocoduck, to use one creationist's stupid example, would create a loop in the nested hierarchy. If we ever found such a creature, evolution would be done for, despite the creationists saying it's necessary. No, the fuzziness occurs as you move down a branch and it splits off. We want to place a marker somewhere saying that now it's a new species, but this is the part where it gets fuzzy. Take a look at Tiktaalik again. Tiktaalik is in the class Sarcopterygii, or lobe-finned fish, but its subclass is Tetrapodomorpha, which is the branch leading to the superclass Tetrapoda. Fish and tetrapods are all vertebrates, chordates, animals, and eukaryotes, but the difference between their classes is enormous. Nonetheless, Tiktaalik and its fellow transitionals represent intermediate steps between lobe-finned fish and tetrapods, just as in the lower ranks of dinosaurs and birds. We see them as being so much more different only because this happened further back in time, and the dinosaur-bird split happened fairly recently, but that's the only difference. 200 million years from now, future biologists might look back on the dinosaur-bird transition, or even transitions between smaller ranks, like 2 different species of finch, as being incredibly great changes between 2 large groups. So if biologists ever decide to use fuzzy sets to classify species, they could have Tiktaalik as having equal membership in both the lobe-finned fish set and the tetrapod set. It's still mostly arbitrary. The set limits could be moved wherever and called whatever, and it would still be equally valid as far as nature is concerned. All nature does is make small changes to descendants, which accumulate over time into things that humans call categories, but which nature isn't concerned with at all. So now, when you hear a creationist say that a fossil can't be transitional because it's fully formed, or that fish only give birth to fish, or anything like that, you know that the problem is with their extremely limited black and white thinking.